So we'll start with the lecture that is disjoint sets, partition, that is partitioning of the sets, ordered sets. We have seen so far the sets are unordered. You can write in any order, but there are some terminology available which is called ordered sets, or we can also say those are also said to be n tuples. That we'll see afterwards. Cartesian products of the sets. What are the conditions that were supposed to be remembered when you go for the Cartesian product, and whether the Cartesian products are just like what are the operations that you perform on the Cartesian product is also similar to the set unions and intersection. Let we will see the comparison of them. So disjoint sets. Disjoint means there should not be anything in common in the two sets. Okay? So then only we can say those two sets are disjoint. Two sets are called disjoint if their intersection is empty. A and B are disjoint if and only if A intersection B is equal to none. Okay? So here in the diagram there is a universal set which having several elements, and B and A sets are there. There is nothing, no element in this particular diagram is in common. So hence B and A are disjoint. So here in this example, A is equal to 1, 2, 3, 6, B is equal to 4, 7, 8. Whether these two sets are disjoint? Yes. These are disjoint because no element is common. Now n tuple. See, wherever the tuple is the word come into the picture in computer science, you need to remember it as a row or record. Okay? Tuple means a particular record, a row. Okay? This kind of things. In database also you will get this particular word tuple, and in many places you will get this particular word in computer science especially. Okay? So n tuple means n rows or n records, this kind of things. While coming to the set theory that what we have seen in the previous lecture is every set consisting of the unique elements. Okay, unique elements 1, 2, 3, 4 like that. Okay, but why can't it be as a combination of 2 or 3 elements? Okay, that is what we call tuple here is. So if you look at the definition of the sets, sets are used to represent unordered collections. An ordered pair is defined as, that is n tuple is an ordered pair. Okay, please remember. An ordered pair is defined as a set of two objects together with an order associated with them. Ordered pair are usually written in parentheses as opposed to the curly braces that we will normally write in the sets. For example, if I want to mention coordinates of a point. So the coordinates of the point on the two-dimensional plane is x comma y. Right? So here I am going to mention it as a unit, single unit. Okay, these are not the individual elements, these are the single units. That is the coordinate of a particular point. So this type of data is said to be the ordered set, you can say. So here is an example given below. Coordinates of the point in the two-dimensional plane is 12, 16. Okay. So this is what they called the representation of the n tuple. Cartesian product. The Cartesian product is whenever you go for the product, what will happen? Obviously you will go for multiplying of one element with the other element. Here the Cartesian product is you are making the combinations from one set with the other set. Okay. Definition. Let S and T be the sets. The Cartesian product of S and T denoted by S cross T, just like your multiplication cross, is the set of all ordered pairs S comma T, where S belongs to S and T belongs to T. So here, because we got an idea of the n tuple, which is the ordered pair, the Cartesian product will give you the ordered pair of elements. Okay, which is S comma T, small s comma small t. S is equal to 1 comma 2 and T is equal to A comma B comma C. Now how can you make the ordered pair here? The first element in set S with the first element in the set T. Next the first element in the set S with the second element in the set T. Like that you make the ordered pairs. Okay. So S cross T is equal to 1 comma A, 1 comma B, 1 comma C, 2 comma A, 2 comma B and 2 comma C. Right. This is the way you make the ordered product. In multiplication in general, 2 into 3 is equal to 3 into 2. Right? But in case of the Cartesian product of the sets, this will not hold. S cross T is not equal to T cross S. Why? The ordering of the pair of the creation will differ from S cross T to T cross S. If you look at here, S cross T, 1 comma A, 1 comma B. But in case of T cross S, A comma 1, B comma 1. Right? So here the pair is different. The ordering of the pair is different. That is the reason, note that S cross T is not equal to T cross S. Right? Next, Cartesian product of several sets. That is, Cartesian product may also be defined on more than 2 sets. Here so far we have seen S and T, which are 2 sets. But we can also perform the Cartesian product on multiple sets like A cross B cross C cross D, like that. Let A1 comma A2 comma and so on, A and be the n non-empty sets. The Cartesian product of A1 cross A2 cross and so on cross AN is defined as the set of all possible ordered n tuples like small a1 comma small a2 comma small a3 and so on small an, where ai belongs to capital AI and I is 1 to n. If a1 is equal to a2 is equal to a3 is equal to an, that means all these sets are same. That means the number of elements that are held in these sets are same. Then a1 cross a2 cross a3 and so on an is called as the nth Cartesian product or nth Cartesian power of the set A and is defined as A power n. It is just like in the multiplication, 5 cross 5 is considered as the 5 square. Like that we will also consider in this case, if the set, the multiplication, okay, the set is of the same set that we are going to multiply, then the nth Cartesian power is considered as A power n. And these are the properties of the Cartesian product that you must remember. The Cartesian, first one is, the Cartesian product is non-commutative. As just now we discussed, A cross B is not equal to B cross A. Okay. But if B is equal to A, then A square is equal to A square. That is acceptable. But if two different non-empty sets, okay, if multiply, that is Cartesian product, is not equal to its reverse. A cross B, second one is A cross B is equal to B cross A if and only if A is equal to B. Just now we discussed it. A cross B is equal to phi or null if either A is equal to null or B is equal to null. It is just like multiplication of 0 with anything is 0, just like. The Cartesian product, next fourth one is, the Cartesian product is non-associative, that is A cross B cross C, that is A cross B within the brackets cross C is not equal to A cross within the brackets B cross C. The distributive property over the set intersection A cross B intersection C is equal to A cross B, that is whole, intersection A cross. Distributive property over set union, if you look at A cross of B union C is equal to A cross B union B cross A cross C. Seventh one, distributive property over set difference A cross of B minus C is equal to A cross B whole, okay, minus A cross C. We have seen yesterday the subset if A is the subset of B, then A cross C subset B cross C for any set C. What is meant by proper subset? How we will represent proper subset? As in the last lecture we have seen, there will not be underline in the subset representation. Cardinality of the Cartesian product, how we will see the cardinality? So in general, the number of elements in a set is the cardinality of the particular set. But what is the case of the Cartesian product? The cardinality of the Cartesian product of two sets is equal to the product of the cardinalities of the sets. S cross T is equal to the cardinality of the S into the cardinality of the T. That is what the cardinality of the. So if for example, you consider two sets, cardinality of the set A is 5 and cardinality of the set B is 4. Then the cardinality of the Cartesian product of A and B is 20. Right? Similarly, A cross A1 cross A2 cross A3 cross and so on AN is equal to the cardinality of A1 into cardinality of A2 into the cardinality of A3, like that, and so on, cardinality of AN. So here are the examples given. A is equal to JPM, B is equal to RAL, A cross B is equal to JR, that is the combinations that we can make. Then A cross B is equal to 9, A is equal to 3, B is equal to 3, which is because the number of elements in the set A and B are 3 and 3, where coming to the Cartesian product of A, B is 9. Partition of a set. This is another concept that we are going to see here. Partition. Partition is nothing but you are supposed to always remember, if you take a particular unit, single unit, you can have any number of partitions in it. But whenever you combine all these partitions, it should result into the original unit. Okay? This is what the principle that will be used in the partition of the sets. Partition of a set A is a collection of disjoint non-empty subsets that have A as their union. So that means you can divide the particular set in any order, in any form, but if you combine all the subsets, okay, then it must result into the original set without any loss. Okay, there should not be any loss. The union of the subsets of P is equal to A, union I is equal to 1 to N, AI is equal to A1 union A2 union A3 and so on, AN is equal to A. So here is the example. The list of examples are like this. So here, list all possible partitions P1 1 2 3 1 comma 2 3 1 3 2 1 comma 2 comma 3 and 1 2 3. So these are the ways, different ways of dividing a particular set into multiple sets. Given A is equal to 1 2 3 and B is equal to 1 comma 2, find the following sets: A cross A, B cross A square. You can easily do it. Given A is equal to DEF and B is equal to EF, find the following sets: A cross B intersection B cross A cross B union B cross A. And next one is find the Cartesian product of A cross power set of A. Power set of A means all possible subsets of A, including null. Right? So if A is equal to A comma B, let A is equal to B1, B2 and so on Bn, compute the cardinality of the set P of A power M. So you can take M value, whatever, a little bit higher value like 4, 5 like that. You can do it. And this can be easily done by you. Which of the following collections of the subset are partition of the 0, 1, 2, 3, 4, 5? Okay, you consider the subsets which are given in the listed in the multiple choice and union them. If it is leading into 0, 1, 2, 3, 4, 5, then that is the possible set. Right? So in the previous example we have seen, okay, one particular set may be having multiple subsets. Okay, when you add all these subsets, then it is leading into the original subset. So this is related to the topic of the subsets, disjoint sets.